Okay, ladies and gentlemen, I'm at 61 subscribers.
Yay! Yay!
No, I did not egg on that applause. So remember to subscribe. I'm going to do a giveaway at 100, so make sure you hit the subscribe button. Comment on any math problems that you'd like during the video. I take requests. All right, here we go.
I think he's one of the worst YouTubers.
Oh, that's great. All right. So just as a reminder, everybody watching along at home, you should be taking notes over section 7.5. Everybody down at the New York City trip meeting, I will want to see your guided notes. Make sure you pick those up. Did I give them guided notes? Yeah. No, I did not give them guided notes. Well, hopefully you'll get back in time and I'll give you the guided notes and you'll be all right. But make sure to finish the guided notes and do the homework. If you found the video, you found the homework because it's right next to it. Okay, good. All right, so section 7.5, polynomials. So what we're going to talk about today is kind of working off what we did before, where we were talking about how do we add, subtract, multiply exponents, right? Well, what if we have, what do you call it when we have a multi-termed equation? What do I mean by term? I mean anything separated by addition or subtraction. Well, that's called a polynomial, basically. That's called a polynomial. So the most basic form that we can get is called a monomial, and that's the first thing you see there. A monomial is a number, a variable, or a product of number and variables. The prefix mono meaning one, right? Mono means one, single term, okay? You have one term. Should you see any addition or subtraction when you have one term? No, you should not see any addition or subtraction. So take a look at some examples that you see there. And again, this is on your guided notes. So here are some monomials and here are some not monomials. Like the number 5, you can consider a monomial. X is a monomial. Negative 7xy, yes, it can have more than one variable as long as it's not separated by an addition or subtraction sign. 0.5x to the 4th, sure, it could have an exponent on there, that's totally fine. Just as long as there's not an x separated by a plus or minus. Here's what you can't have. You can't have anything raised to a negative exponent. It's got to be a whole number exponent. You cannot have a subtraction sign in between two terms. And you cannot have any x to the thirds or anything on the bottom, right? You can't have any x squared, any exponent on the bottom, any variable on the bottom. No good. Now, we're going to be talking about the degree of monomials and polynomials. So we've got to start out with our most basic monomial. The degree of any monomial is the sum of the exponents of the variables. The degree of a monomial is the sum of the exponents of the variables. Can you underline the word sum there for me? What does sum mean? What does that mean? Addition, right? You add up the exponents of the variables. Okay, you add up the exponents of the variables. If there are no variables there, if it's a constant, the degree is 0. Okay, so let's take some examples. Okay, maybe I'll just scroll it down. So, do you guys see how this is a monomial? Do we all understand that this is a monomial? Do you see any addition or subtraction going on between any of the numbers or variables? No. This is one term. It's a monomial, right? One. All right. So if it's a monomial, the degree is add up the exponents of the variables. So what's my degree? 7. Yep. Pretty simple, right? The degree is just 7. Okay. You have no idea what that's used for yet, right? This number is just like a random thing about the polynomial. You have no idea what it's used for yet. I promise you more to come later. Okay, what about 7ED? We all see that this is a monomial, correct? One term. So add up the powers on the variables. So what's my degree of this monomial? 2. 2. 1 here, 1 here. Now, I bet some of you thought 3. I bet some of you thought 3. Why? Because the power here is also 1. but you only look at the powers on the variables. So the degree here is 2. Does that make sense? Okay, again, you have no idea what the degree is or what it's used for, but for right now, we're just identifying what they are. Okay, this is, again, a monomial. It doesn't have to have variables to be a monomial. It's just one term. What's my degree here? 0, right? When there's no variables, the degree is 0. When there's no variables, the degree is 0. Last one on this set. What's my degree here? 3. My degree is 3. Exponent of 2, exponent of 1. The degree is 3. Okay, so that's the degree of a monomial, single term. Single term. So what if we start putting plus and minus signs in there? I said that for it to be a monomial, there couldn't be any plus or minus signs. So what if we start putting plus or minus signs? Well, then we have to start calling it a polynomial. And again, you guys have this. A polynomial. A polynomial is either a single monomial or a sum or difference of monomials. Yes, you can still consider a monomial a polynomial. I know it seems weird, but it's kind of like under that umbrella. Yeah. We have the term polynomial, just like I call you all 9th graders, right? You're all freshmen. Under that umbrella, aren't you all like students of Mr. Laverick, right? But you're still 9th graders, right? Okay. Just like monomials. I can call something a monomial, but it's still a polynomial, right? It's still got that overarching term of being a polynomial, but it's just a little bit more narrowed down. It's just a monomial, okay? Now, how do we find the degree of a polynomial? If the monomial, we just add up the exponents. What if I have a bunch of different terms? Well, basically, you just take the degree of the term with the biggest degree, okay? The degree of a polynomial is the degree of the term with the greatest degree. Okay, now what does that mean? Let's take a look here. Find the degree of the polynomial. So here's what we have to do. We have to go through every term and find the degree of each term. Okay? We got to go through every term and find the degree of each term. So that's what I'm going to do, and I'm going to do it right underneath it. What's my degree of this first term? What's my degree of the first term? 7. What's my degree of the second term? 3. What's my degree of the third term? 0. What? Now, don't add them up anymore. Don't add them up anymore. That's a very common mistake. You don't add these up anymore. You just take the biggest one. What's the biggest number that you see? So the degree is 7. Okay? That's a very common mistake. Don't say 10. The degree is not 10. The degree is just 7. Okay, let's take a look at the next one. Don't get thrown off by the fractions. What's the degree of this first term? Do we all notice that there are 3 different terms? If you wanted to, separate them by the addition and subtraction signs that you see. I see 3 different terms. Okay, so what's the degree of my first term? Remember, add up the exponents. I've got a 2 and a 1. That makes 3. What's the degree of my second term? 4. What's the degree of my third term? Okay, what's the biggest number that you see? So the degree of the entire polynomial is 4. Questions about that? Okay, let's keep it moving. What's the degree of my first term? 1. The degree of my first term is 1. What's the degree of my second term? 0. What's the degree of the entire thing? 1. Remember, the highest degree wins out. The highest degree wins out. Let's take a look at our last one here. What's the degree of my first term? 5. Second term? 5. Third term? Last term. Okay, I see 2 of them, but what's the biggest one? The degree is just 5. Does that make sense? Highest term wins out. Okay, so again, you have no idea what that's used for yet. Trust me, we will talk about that. But that is a very important number that's associated with the polynomial. The degree is an extremely important number. All right, the terms of a polynomial may be written in any order. However, we need to talk about what's called standard form. We've learned a standard form before. We talked about standard form of a linear equation. That was that ax plus by equals c. But now what we're going to talk about is standard form of a polynomial. When we have multiple terms, okay, and they're all raised to all sorts of different powers. Standard form of a polynomial, as long as it contains one variable, is basically ordered from greatest degree from least degree. Can you underline greatest degree to least degree? The standard form of a polynomial that contains one variable is written with the terms in order from biggest to smallest, greatest degree to least degree. Okay? So if I ask you, put your answer into standard form. Put your answer into standard form. Just like look at example 3 down there. Write each polynomial in standard form. When you put your answer into standard form, you're going from biggest degree to smallest degree. Now, when it's in standard form, the number out front, the coefficient of the first term, is what's called the leading coefficient. Again, a number that we're just going to identify today. I'm not going to tell you what it means yet or how to use it yet. Trust me, you'll get there. But the leading coefficient is just the number out front. And don't forget, if there's ever a variable with no coefficient, the coefficient is just 1. Okay. All right. By the sounds in the hall, it sounds like they're coming back. I'm just going to use this.
Yeah.
Hi. Pick up a guided notes on the way in. There you go. The video's rolling too, watch out. All right, so write the polynomial in standard form, then give the leading coefficient. All right, so let's underneath each term, just like we did on the last example, let's write down all the degrees. You guys may be able to see it right off the bat, but let's write down the degrees. Go ahead and pick up a guided notes there. Okay, so what's the degree of my first term? 1. What's the degree of my second term? Third term? Last term. Okay, now let's go in order from greatest to least. What's my biggest degree here? The 5. So this term is going to go first. The whole thing is going to go first. Negative 7x to the 5th. Okay, what goes next? Pick up a guided notes here. 4x squared is going to go next. A positive 4x squared. Pick up a guided notes. Pick up a guided notes. Pick up a guided notes as you come in. Plus 6x plus 9. Do we all see that? That is what's called standard form. That is what's called standard form. Standard form goes in order from greatest to least as you continue through highest degree down to smallest degree. So, what's the degree of the entire polynomial? What's the degree of the entire polynomial? What's the degree of the entire polynomial? 5. The degree is 5. And what's my leading coefficient? Kenzie, pick up a guided note there. What's my leading coefficient? What's the number way out front? Negative 7 is my leading coefficient. Again, we have no idea what that's used for yet. All we're focusing on is, can you identify it? What is it? Okay? We'll talk about what it's used for later. But for right now, we're just talking about can you identify what it is? Okay. So let's do another one here. Now, if you're getting to the point, if you're getting to the point where you can identify the degree without writing it down underneath it, by all means, go for it. But I'm going to keep on writing the degree. What's the degree of the first term? What's the degree of the first term? 2. What's the degree of the second term? What's the degree of the third term? 1. Right? Okay, now, highest degree is y to the 6th, and then it goes y squared, and then down to the 3y. The degree of the entire polynomial is just the highest degree of each term, so degree of 6, and then the leading coefficient, you'll see me abbreviate leading coefficient as LC. What's the leading coefficient on this? What's the number sitting out front? 1. 1. A coefficient is just a number. There's no variable associated with it. Coefficient is just a number. It's just a number sitting out in front of the variable. So the leading coefficient, once you put it into standard form, is just a number sitting out front. Isn't there like a 1 always written out in front of there? Yeah, so it's just a 1. Let's take a look at the last example from this set. We got 16 minus 4x squared plus x plus 9x to the third. So again, writing it in standard form, going from biggest to smallest in terms of the degrees. Let's write out what each degree is. What's the degree of just 16? 0. What's the degree of 4x squared? 2. Degree of x to the 5th? 5. And then 9x to the third is just 3. Biggest degree is the x to the 5th, and then we go down. 9x to the third, and then minus 4x squared plus 16. The degree of the entire polynomial is 5. Biggest one wins out. And then the leading coefficient is 1. Okay? So again, standard form going in descending order. Can I point something out to everyone? Make sure that you see that I only had one variable for all 3 of those examples. Guys, I will never ask you to put something into standard form when I have more than one variable. It's not possible. Okay? Standard form only exists when you have one variable. So if there were x's and y's, like look at example D from above. I would never ask you to write that into standard form because there's x's and y's. Look at example B. I would not ask you to put that into standard form because there are w's and z's. You can only put something into standard form that has one variable. All right. So now that we've identified leading coefficients and degrees, let's talk about the names because it's important to learn how to speak about the polynomials. Right? You got to learn the language a little bit. So, looking at the number of terms, there's 2 ways to talk about a polynomial. When you talk about it in terms of how many terms there are, and then what's the degree of that polynomial. Those are the 2 pieces of information that you need to name a polynomial. So, the first one, looking at the number of terms. Okay. 1 term, monomial. We learned that at the beginning of class. Monomial. Prefix mono meaning 1 or single. Monomial. An example, heck, 3x. That's just 1 term, right? As long as there's no plus or minus signs in between there, it's just 1 term. Monomial. Mono. Okay. The prefix is going to change. Instead of monomial, it's going to change. Binomial. Oop, I almost showed the third one there. Binomial. Just like you got 2 wheels on a bike, right? Bicycle. The bi prefix meaning 2. Bicycle. Binomial. 2 terms. 4x squared plus 2. 2 terms. There are 2 terms. If it's 2 terms, you call it a binomial. So if we've got 2 terms as a binomial, what do you think 3 terms? Trinomial. Trinomial. Oh, I almost showed the last one too. Trinomial. An example. 3a to the 4th plus 2a minus 1. 3 terms. Trinomial. Trinomial. Now, anything beyond that, you just call it a polynomial. Now, don't get me wrong. 3 terms, you can still call a polynomial, but it's got a more specific name. It's got a more specific name. You call it a trinomial. Just like I was talking about earlier today, you are all 9th graders. But more narrowed down, you are 9th graders that are also in Mr. Laverick's class, right? So while I could still call you all 9th graders, we can get a little bit more specific than that. Same thing here. I can still call all of these examples polynomials, but we can get a little bit more specific. We can call this one a monomial. We can call this one a binomial. We can call this one a trinomial. Anything with 4 or more terms, there's no more specific name. You just call it a polynomial. That's it. Okay, so we not only have the number of terms, but we also have the degree of the polynomial. Now this is where it starts to get fun. Monomial, binomial, trinomial, that's pretty, pretty straightforward. Here's where it starts to get a little fun. If it's a degree of 0, you call it a constant. Constant. Guys, what kind of polynomials have degree of 0? Thinking back to our first couple examples, what kind of polynomials had a degree of 0? They were just numbers, weren't they? Like 4. Any x associated with it? No. Right? If there's no variable associated with it, the degree was 0. Okay. Degree of 1, we call that linear, which makes sense. It forms a straight line, like a 3x plus 1. The degree would be 1 of that entire polynomial. Actually, if I wanted to get really specific, I would call that a linear. How many terms do I see? 2 terms? I would call that a linear binomial. Linear binomial, because I see 2 terms. That first example that I had was a constant monomial. Constant monomial. Okay. Degree of 2, it's called quadratic. Now, we haven't studied quadratics just quite yet. We'll study quadratics pretty soon here. Next chapter, I believe. Chapters 8 and 9, I think. Quadratics. So that's like saying a 4x squared plus 2x minus 1. Quadratic. If it's got a degree of 2, you call it a quadratic. I would call this one a quadratic trinomial. A quadratic trinomial. Degree of 2 with 3 terms. 3 terms would be called cubic. Cubic. X to the 3rd minus 4. Sure. If it's got a degree of 3, then you would call it cubic. I'd call that one a cubic binomial because it's 2 terms. Degree of 4 is called quartic. 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 I remember quartic by how many quarters are there in a dollar? 4. So like this one, I could say x to the 4th minus 2x to the 3rd plus 2x plus 4. What would you call that one? What would you call that one? A quartic what? Polynomial. Polynomial, right. There's no more specific term that we can use other than polynomial. 5 would be quintic. Quintic. Some of you might recognize that prefix, the Q-U-I-N. Anybody take Spanish? What's 15 in Spanish? Isn't it spelled exactly like that? Q-U-I-N-C-E, right? Q-U-I-N, that same prefix. I know it's not 15 degree, but obviously 5 in it, right?
That's getting confusing now.
Like x to the 5th plus 1. That would be a quintic binomial. Quintic binomial. Okay. Now, anything above 5, you use that number. We don't normally get things above 5. Okay, but if you do get something bigger than 5, you just call it a 6th degree, or 7th degree, or 8th degree, or 9th degree. Okay, anything above 5, you just call it that, and then the degree. You know, like if you have an x to the 10th, I don't know, that's pretty big. You would call it a 10th degree polynomial. Questions about that? Okay, so let's name some. We're going to sound really smart. You can sound really smart when you name these things. Okay, let's name this. Let's name this. Let's first start by identifying the degree, and then identifying the number of terms that there are. Okay, so what's the degree of this polynomial? What's the degree of this polynomial? What's the highest power? It's 3, right? The degree is 3. So what would that be? What would we name that as? Cubic. How many terms does this have? 2 terms. So what would we call that? Cubic binomial. A cubic binomial. Gotta learn the language a little bit. Right? Gotta learn how to name these things. Let's try another one. Is this in standard form? The last one was. Is this one in standard form? You should always check. Yeah, it's in standard form. It's going from biggest to smallest in terms of the powers, in terms of the degrees. What's my degree of this? The degree is 6. How many terms does this have? 1, 2, 3, 4 terms. Okay, so if I've got a degree of 6, does 6 have a name? No, we just say 6th degree. Does 4 terms have a name? Just polynomial. We call that a 6th degree polynomial. Let's try this one here. Negative 2x. Okay, what's the degree? The degree is 1. The degree is 1. How many terms do you see? 1. Try to identify it for yourself real quick. Don't say it out loud. Just try to think about what you would call this thing. Okay, somebody tell me what they think.
Linear monomial.
Linear monomial. Good. Linear monomial. Linear monomial. Questions about that? Okay, and our last one for this set. What's my degree here? 2. The degree is 2. How many terms do you see? 1, 2, 3. So we would call this a quadratic trinomial. Quadratic trinomial. Question about that? Okay. All right, last problem there. Polynomial is used to estimate the stopping distance in feet of a car whose speed is v miles per hour on flat dry pavement. What is the stopping distance for a car traveling at 70 miles per hour? Guys, what is that telling you to do with 70? What's that telling you to do with 70? Just plug it in. Yeah. It's a lot of words there just to say, plug it in. Okay? Here is my function. Here's my equation, 3.675v plus 0.096 v squared. And I say v is 70. Just plug 70 in. So I'm going to go into my calculator here, and I'm going to say 3.675 times 70 plus 0.096 times 70 squared. 727.65. 727.65, what's this, feet? Yes. You know, it's kind of interesting to point out that, yes, indeed, that is true. You can actually model safe stopping distance of a car by a quadratic equation, by a quadratic. That's pretty interesting. You know, when they decide how long to make the yellow light run in a traffic light, right? It's all taken into account by the speed limit of the road. So if you're traveling at the speed limit, you know, they calculate the yellow time with stopping distance, safe stopping distance. So they say, okay, the moment the yellow light hits, we need to give you enough time for it to turn red for either you to stop safely or to make it all the way through the intersection. They use a bunch of math to figure out the exact time a yellow light needs to stay on. From the moment it hits it, it gives you enough time to either stop safely or continue through the light. All right, so again, I'm going to stop the recording now. But again, if you, I'm up to 61 subscribers. Let's refresh and see if I've gotten any subscribers during class today. Nope, still 61. So if you have not, or if you came in partway through the period, make sure that, bye everybody.